Howdy everyone, this is Ben, and today I'll be going through how to do U.S. Coast Guard 557 and U.S. Coast Guard 607. These types of tide problems are when you are trying to find the earliest time available you can complete a passage. So let's read through 557 and see what given information we have that we can put down on our high of tide calculation form. I covered all of this in the first video, so if you haven't seen that, I highly suggest watching it, as it will make the terminology I will use in the second video a lot easier to comprehend. In 557, the title reads as the following. The vessel has a draft of 23 feet. On June 23rd, 1983, you wish to pass over a temporary obstruction near Beaufort, South Carolina, that has a charted depth of 22 feet. Allowing for a safety margin of 3 feet, what is the earliest time after 1600 daylight savings times, ZD plus 4, that this passage can be made? Like I said in the first video, let's take this step by step. DST ZD plus 4 basically crosses itself out, but you still have to account for daylight savings time on your sheet. So we'll go to a sheet, and it looks like this. This is 557, and there is daylight savings time, ZD plus 4, and then DST, daylight savings time, which means it's on the ZD plus 5 meridian that this whole reference table refers to. Now the date is 23rd of June, 83. All these are 1983 because that's the ones that the Coast Guard uses. Time desired is after 1600. So that is our initial information that we have for the top. But on this problem, we have some additional information given throughout the problem. So let's go through that right now. So if we go to the bottom of the sheet, calculations of tide for the desired time. So we are given a few pieces of information. It has a charted depth of 22 feet. Put that down. Actual depth of water. This is what we're trying to find. The actual depth of water is also known as the required height that this needs to be for this passage to be made possible. So we're going to put just slash RH right here, just so a little note for us. Our draft is given in the problem, and it's given on the first line, and our draft is 23 feet. So 23 FE. And clearance is the same thing as a safety margin, so we're going to put that in for 3 feet. Now, a formula that you can use to find RH is as follows. D plus C minus CD equals RH. I put parentheses around this just to remind me. So, draft plus clearance minus the charted depth is the required height you need to go to be able to make this voyage possible. So 23 plus 3 is 26 minus 22 is 4. So the required height we need is 4 feet, and we will be using this throughout the on the last part of the problem, or like the last third of the problem. So this is where our time goes in this box. So we'll put 4FT right here to show that we are solving for time in this problem. We are not solving for the height like the last problem. All right, now that we have all of our given information on the paper, we now want to go to the reprints. So let's mute this and head over to the reprints. We're going to first copy over this right here. Remember, you need to push Control F to do that. And then I erase the comma and hit enter. Now, you need to find Beaufort, South Carolina. This is North Carolina, outer coast. So there's two here. Now, this is Parris Island, Beaufort River, and this is Beaufort River. This is the one we are looking for. Also, we know it is the correct one for this problem because it has the time differences up here and not the ebb ones like it would in the flow and ed type problems. So, now that we know we have found the right one, we're going to copy down the correct substation number for this line of text right here. There we go. Got that all on a line. So we can clearly see that it is substation number 2683. Remember, if we actually had the tide table books, we would need this number from the index. But since we don't, it's just kind of nice to have it. And now we need to figure out what reference station we're going from. Now, as you saw in the last video, as I'll point out again, it will be right here. It will be on, whatever it says on after and referring to down here. So this one's on Savannah, referring to this, on Savannah River, referring to these. This one's on Savannah River, entrance, page 100. So you don't really need to copy down all of it. I'm going to put SRE, just remember that it's entrance. But the big piece of data right there is page 100. And sorry, let me turn my cam on. So it is page 100, Savannah River entrance. Now, we still need to copy down these 4 pieces of information right here before we go to SRE. So let's close that. And let's copy down the given information. 1 plus 1H, 13 minutes for high water, plus 0H, 46 minutes for low water, plus 0.5 for high water height, and 0 plus or minus 0.0 for low water. Now that we have that, we want to go to where page 100 is. Like I said in the last video, I'm currently on PDF page 100, and this is showing as 224, which obviously is not page 100. So we need to find page 100 in here, and the best way to do that is just keep on going. We know we're going to be in tide table 1 because it is the middle section. So, oh, there it is, page 100, which if you're finding on the PDF is page 62. So, we're not in January, February, or March, so we want to go down to June. And that will be found on page 63 of the PDF. So we're on June 23rd is the one we are finding times for. And it would be this box right here. So let me zoom in just so you guys can see that better. So copy it down on the screen. Okay. And now I can display my, move that over here. Cool. All right. So we were able to see all of our information just to the right of the camera for your ease. So we're trying to find after 1600 daylight savings time. To do that, we need to find the 2 times that are between 1600. But as you remember from the beginning, this is on daylight savings time, so we need to account for the extra hour. So I will be using 1235 and 1907. We need to add 1 hour. 1235 is the low tide, so it would be 1335, which would be negative 0.4. And high water would be 2007 instead of 1907, and it would be 7.7. Because we do not use the right column. Right column is meters. Bad. Alrighty, now that we have that, we need to account for the time differences and height differences from the reference to the substation. So let's 1335, and let's add and over here 2007. What is helpful to me is if you label it. 1235 is the low tide. 1335 is low now. Low water. This has to be high water. Now that we have that, we want to make sure that we add the correct ones to it. So high water, 1 hour 13 would be added right here. So it would be plus 0113 plus 0046. So 30. So I put my calculator in here. 35 plus 46 is 81 minus 60 is 21. And then you add another hour over here, so it's 1421. And that would be the low water tide. And since we're already doing this, let's add in the low water height difference, which is absolutely nothing. So negative 0.4. So 2007 plus 1 hour 13, which would be 20, 21, 2120. So let's put that right here, 2120. Now we need to account for the height difference. 7.7 plus 0.5 is 8.2. Now that we have that information, we can do the rest of the problem from there. So you're trying to see as we're see less room on the page, the closer we're getting. So duration of rise and fall, same as we did in the last one. It'd be 2120 minus 1421. So make that 20, make this 80. 80 minus 21 is 59. And 20 minus 14 is 6. So it would be 06H, 59 minutes. The time from the nearest tide is what we're trying to find. So we don't really need to worry too much about that. Let's enter this real quick so that a better view of it. There we go. So time from nearest tide is what we are trying to find. But we can't find the range of tide, which is simply 8.2 minus a negative, which is plus. So 8.2 plus 0.4, which is 8.6. Now, this is the extra step you have to do for these types of problems. So you're going to put an L and an H. And remember that that 4 feet we found in the beginning? We're going to be using that again. So for L, we're going to put 4.0. And we're going to be minusing a negative 0.4. For high water, we're going to put 8.2 minus 4.0. 4.0. We are using these two numbers right here because they are what are found right here. On the low water, you take what you're trying to find and you subtract it, and on high water, you take your given height and you subtract what you're trying to find. So between these two, whichever one is lower is the closer tide. So 8.2 minus 4.0 is 4.2, and 4.0 minus a negative 0.4 is 4.4. So as we see that, the high water is what we're going to be using to find. And actually, another thing, 4.2 is your correction. And your height of your nearest tide is 8.2. So now we just need to find the tide from the nearest tide, which is actually what we're about to do. So 2120 and 8.2 is the is what we're subtracting from to get the correct time. Our correctional value is going to be 4.2. So now we just need to find this time. Well, how do we find that time? Right here. That'd be pretty nice, wouldn't it? Well, we got a handy dandy chart for that. Table 3. Table 3 has the rest of the information we need to solve this problem. So we are given the fact that we have a range. We are given all the information on here. So the range of tide is 8.6, which we'll use 8.5. And it's really hard to see. That's why I really recommend just printing this out. And the correctional factor, which is right here, is 4.2. So we're going to go 8.6, which is 8.5, all the way over to here, which is 4.2. Now, that our correctional factor that we just found. Now that we have 4.2 right here, I'll go with that and go over to where it intersects the duration of rise and fall, which we found to be 6 hours and 59 minutes, which will just round up to 7 hours. So we come across and we see that it is 3 hours and 30 minutes. Nifty. So we'll put 0330 right there. Now, put our table 3 to the side, and all we have to do is solve. So 8.2 minus 4.2 is 4.0 feet, which we are trying to solve for. And 2120, 20 minus 30 is not going to be positive, so we need to take one from that. That'd be 20. This would be 80. 80 minus 30 is 50. And 20 minus 3 is 17. So, at 1750, the height will be 4 feet. And this one problem took a lot longer than anticipated, so I will be solving for 607 in the next video. Thanks for your time.